Okay, well, good evening. And so you see the title. Fortunately, Paul mentioned earlier that it relates to astronomical observing. I didn't really put that in the title. And so, of course, I'm here all the time to encourage enjoyment of astronomical observing. And so this smoke forecasting relates to trying to observe the sky through the smoke. I set up a few little subjects set up as a sort of an outline, and so why do I care, and a few resources to use, and a couple of examples, and has it ever happened before, and then a quick summary, and we'll be done. And so who cares? And so it matters when the transparency of the sky becomes really poor, and so a cloudless daytime sky becomes white instead of blue. And so coincidentally or not, today was a very good example of this. You may have noticed the sky this morning was blue, as in the picture in the bottom. I try to put pictures on most of the slides so I don't throw up a slide full of text and nothing, so I put up a pretty picture sort of thing. That's the idea there. So anyway, the point about today was it got cloudy, and then you may or may not have noticed it cleared up this afternoon, became less clouds, but a big layer of smoke moved over us this afternoon. So the sky transitioned from blue this morning to white with smoke cover this afternoon. So today happens to be a very good example, coincidentally. But the point about trying to observe through it is that we can observe some stars, diminished brightness of stars and planets pretty well, and the moon, and some other things like stellar objects like open clusters and maybe globular clusters. But for faint extended objects, forget it. It means that trying to observe, say, a 12th magnitude galaxy, it's a faint fuzzy through a smoky sky is really much more of a challenge than when you have a transparent sky. So it's quite a observing challenge when you have some smoke in the way. A few resources. The resources I want to really promote are observing. A few observations you can make yourself, and I'm combined them with some model data, which you may or may not want to access. But just look at the sky and see is it blue or white. And as I mentioned, today is a very good example. And the other observations to use are visible satellite imagery, which I'll point out in a few examples. As for the forecast models, I'll point them out as well, but they are pretty handy and they can be useful, but they do have some limitations. They are far from perfect. So here's an example of satellite imagery. And so this particular example, hopefully you can see, I can barely see from here with floodlights in my eyes, but you can probably see Lake Ontario split by generally blackness or clear sky to the west of central Lake Ontario, and a big, huge, hazy cloud of smoke covering eastern Lake Ontario and most of the state of New York and eastern Ontario. You may even pick out a spot near Lake Huron that's also covered in smoke. This is an example a few years ago, but it's a very good example. And so it's just one example of many that I've been compiling, but if I had it on a loop too, you'd see the smoke very gradually moving eastward. But anyway, it's just one example. Here's another example, a bit different, because this is a case where it's mostly smokeless. This is an example of a forest fire in Killarney Provincial Park. And so anybody know where Killarney is? Or anybody not know where Killarney is? Some hands are up. Okay, good. So you see that northern lake, northern Georgian Bay, approximately near the center of the image. And you see a streak of smoke extending from left to right. So this is a case of a very local forest fire and a very local plume of smoke extending eastward from the fire. So we can pick this out too on visible satellite imagery. So this is the sort of resource that I want you to use if you want to forecast smoke. See it, find out where it is. Don't rely totally on computer models which may or may not pick it up because they have limitations. And so look at the satellite imagery, separate cloud from smoke. So that's really one of my main points here. The other point is to use, you can, if you want, use modeling. So computer modeling exists in a few examples. This particular example is Environment Canada's model. So I just threw up a web page. I wasn't going to work through too many details of how to get to it, but if you want to pull up your weather forecast page, I left most of the URLs on here, hopefully. So if you really want to see it, you see it at the top, weather.gc.ca. And on that page, you look for analysis and modeling, and at the bottom, you see modeling. I put the arrow to mark off where it marks off their model for smoke forecasting. And when you click on that, then you click on evening forecast or morning forecast. It's updated twice per day. So you click on that, and then you get an image sort of like this. So you see at the bottom, there's a loop, maybe a 72-hour loop, so you can pick one, but I just picked one example, and coincidentally, it's quite recent. It's yesterday, actually. The fact is, I had a few examples set up, and I decided a couple days ago that we had a really, really good example coming up next couple days, including yesterday. So yesterday's model lines up really well with what's on the satellite imagery and what's coincidentally overhead right now. But anyway, the point is, it's an example of a computer model forecast you can get for PM 2.5 total column, as it's called. But anyway, you scroll around at the bottom, you can find some links for some zoomed in images. In this case, the Ontario regional chart. So a bit of a zoomed in image. May give you a bit more information, may not. Anyway, that's one of the models. Another one is one that started off as a few years ago, a decade ago actually, as Blue Sky forecast model in U.S. Forestry Service, and UBC got a hold of it, and it's now called Fire Smoke Canada. So firesmoke.ca is a website. If you click on that, I marked off the arrow to the website spot on the button for the view forecast. So when you click on that button, you can get another 48 or 72 hour, whichever it is, loop. I think it's 60 hours. But anyway, the point is a loop hour by hour of smoke moving across the country. It's a little bit different from the previous one I showed you because this is intended to show PM 2.5, or which is fine particulate matter of 2.5 micron. It's so-called respirable particulate at ground level, affecting ground level air quality. That's what it's intended to show. So it's a little bit different from previous chart I showed, which was total column particulate. Point is, anyway, it's a pretty good map. It's pretty good a lot of the time for showing where your smoke moves across the country or across the continent. You see all those red spots are marking off hot spots, and if you zoom in, I think I put a zoom in image here. Did I? No, I did not. I took it out. So anyway, you can zoom in for more detailed hotspot data. So if you were to zoom in on any particular area, mousey may not work here, but zoom in on any particular area, you'd get a cluster of more hotspots. So that's a reasonable way that they've packaged it together into this website image. But anyway, you can see with increasing intensity where the plumes are more intense. And so anyway, the other one I wanted to mention was the website called astrospheric.com. I noticed a lot of people use this, a lot of amateur astronomers use this, and it's fine, but it has limitations. It's not 100% perfect for sure. But when you pull this one up, it has, I marked off with an arrow, again, a spot you can click on. It mentions layers. And if you click on that, you can click on smoke, and this will come up. And this is a smoke map. And so it's pretty good. As I mentioned, it's pretty, maybe a little bit overdone, but doesn't appear quite that intensely on a satellite image. But it's just a good way of giving a rendition of where the smoke is. And so range of intensity scales. So that's a very good product to use, is that astrospheric.com. Not perfect, but very good. Okay, that's one of the main resources I wanted to mention were the observations, where you observe with your eye and satellite imagery and pick out what you see and decide where the smoke is, as well as forecast models on computers. Their websites, I just showed you a few. There's some other resources you can access. Where are the fire hotspots? The NOAA smoke analysis, air quality maps, ground-based observations. So there's quite a lot of information you can go into if you really want to. There's quite an extensive list of resources online. I just wanted to mention several, and here's one recent example of Natural Resources Canada's hotspots map. This is updated constantly, and so you see, for example, here there's quite a lot of fires burning across the continent, and that's typical in springtime, although this year is not quite typical. It's far worse than typical. But anyway, hotspots map gives you some idea of where a lot of fires are. For if you pick out, for instance, northern Alberta, northern Saskatchewan, southern Northwest Territories, you might guess there'll be a lot of smoke drifting downwind from there. Of course, that's what's happening. Anyway, hotspots map. What else did I put in here? Well, the NOAA analysis, U.S. National Oceanic and Atmospheric Administration, NOAA, puts out this hazard mapping system, fire and smoke product, and some other products as well, text products and some others. But the point is here, at a glance, it's a nice image, nice pretty picture of where smoke is, based on humans looking at it and putting out this analysis map. So you might find that helpful too. I think this is also a fairly recent one, and you see, once again, I mentioned this plume of smoke that was on the model imagery that I showed a few minutes ago that is coincidentally over us right now. So anyway, analysis map. So here's a really extensive, didn't want to go into this too much because there's a huge amount of information on this. If you click on worldview.earthdata.nasa.gov, this particular picture is a satellite image patched together in segments, of course, of North America. Big plume of smoke across northern Ontario. You can pick out numerous layers from hotspots to PM 2.5 to a whole range of things related just to fire, not to mention a lot of other so-called satellite remote sensing parameters that are measured daily and hourly and available for research or for public use if you want to. So it's a huge amount of information on this. Didn't want to go too far into it. So that's just another resource anyway. You can, another resource you could use if you really want to is weather weather forecast charts. And so for instance, if you pick out some upper level winds and plot a map for that, and left a URL sort of here visible here if you really want to look at it. Didn't want to say too much about it. Of course, using weather maps can be very, very helpful, but I know that weather forecasters don't have a really good reputation and don't really go around bragging about being meteorologists or forecasters, and can get tomatoes and eggs thrown at them and so on. So I didn't want to get too far into this. So just wanted to mention it. It is a resource if you want to use it to help you forecast where the smoke that you see on a satellite image may be going. So let's see. I wanted to point out a detail here that the forecast products from computers can sometimes be unrealistically too detailed. And so you see an example here on Astrospheric, and I've occasionally looked at this and wondered what the heck's going on here, and is that realistic, and is that what I see moving overhead in the next few hours? And so I'll tell you, you can occasionally pick out some conditions where plumes of smoke get diminished, where holes appear in them. For instance, following a big thunderstorm cell, the back edge of it can have a lot of subsidence, and it can really dry out the clouds. So you can see a cloud deck and then it being clear in a big spot behind the thunderstorm cell that's moving eastward. And occasionally I've seen the smoke diminish too. So you can pick out a big hole appear in the smoke deck behind it. So I can sort of understand, or once in a while at least, appreciate that the smoke diminishes in some spots, but I don't think I've ever seen it increase in intensity unless there's a fire at that particular spot causing increasing smoke. And that's possible too with thunderstorms. Lightning is the main cause for forest fires, wildfires, and so yes, it can happen, but in a lot of cases I've looked at it and wondered what the heck's going on here, and it's not quite totally realistic. So all I would say here is please be careful if you look at these computer models. So I wanted to point that out. Had a couple of examples. June was interesting this year because smoke was not only clogging up our skies and making deep sky viewing pretty difficult and challenging, but we had a lot of ground level air quality mess in the Toronto area, as well as across Ontario, as across eastern North America, where that smoke came down and caused significant air pollution episodes. But that's not the point of the talk here. So the point was here, I showed a couple of examples of products you can use, and showed you the analysis chart earlier. A big plume of thicker smoke across, central part of the continent, Great Lakes area, and so on, and showed up here in this particular forecast chart, a pretty big mess across southern Ontario, and that was pretty significant in June, various days in June. In fact, most of the month of June. But the other example I pointed out was I reset this presentation up a couple days ago, and I realized this is a really good example coming that was really obvious and probably would still be in effect by the time I do this presentation, which means right now, today. So you see a couple of days ago, the satellite image showed really distinct, huge smoke plume moving southward across northern Ontario. You may have noticed it also on the Earth view image I showed, but anyway, the point here is it shows up really well in satellite imagery. And a couple other products I put in here. So the forecast computer model shows it pretty distinctly. Big mess of smoke. This computer model also showed it pretty distinctly. I might have showed this one earlier, may not have, but anyway, so various products all show a similar thing. And the point here was that point that affects us right now is that this plume moves southward very slowly, and now it's moving eastward across southern Ontario. So that if you notice this afternoon, I may have mentioned this afternoon, the clouds cleared a little bit, and we were left with a very smoky sky as this plume moved eastward. So I decided a couple of days ago, this is a really good example to show. Okay, did I set up third example? I think I took it out. The wind forecast chart, I said I didn't want to dwell on weather forecast products too much. And get, I'll get bricks and tomatoes thrown at me, but point of the upper winds chart is you see northerly winds from mostly the north, northwest, flowing from northern Ontario down towards southern Ontario. So forecast charts can help you out if you want to look in more detail. Wanted to finish off with some longer term forecasts, and there are numerous products online from Canada and USA, huge country to our south, puts out a lot of products, but just from Natural Resources Canada, here's a monthly chart for showing fire intensity, severity, and it's not looking pretty for this month of August. So I wouldn't want to dwell on it too much. So let's look at another product for temperature. Temperature forecast for the next 3 months. It's not looking too pretty either, unless you like nice warm autumns. So, but the point of temperature is that it's one of the factors affecting fire severity. So that if you have a pretty warm summer, as we have right now, and it happens to be dry in the forest areas that tend to be forest fire smoke sources, then watch out. It could be a pretty bad year. And that is a pretty bad year. Did I throw in one more resource? Well, yeah, seasonal forecasts. I didn't want to mention too much about ENSO and the El Nino, but if you have an El Nino situation that encourages Western Canada dryness and warmth, then watch out even more for more fire activity. So if you get a La Nina phase coming in eventually, that can help cool things down a little bit. But this is showing El Nino, and it's a warm phase, and so case to watch out, but I didn't want to say too much about it. Just say that there are a lot of resources you can look into related to weather and climate. Lots of others too. Watch out for blocking situations, blocking ridges over North America, especially in springtime. Also a good case for more active fire season across Western and Central Canada and USA. So a lot of resources, didn't want to say too much about them. Let's see, I wanted to finish off with saying, has this happened before? Yes. So these are pictures, analysis pictures are saved from, I think it was about 10 years ago, maybe. Yeah, 2000, no. Oh, this is 2021. So, but anyway, you see numerous times per year, I've captured these images, saved them for various purposes. I think I had another one, 2008 here. So each year for the past 20 years, I've noticed things. This is just one example that I had. This is in a paper I published when I was employed doing this stuff, but carbon monoxide measured satellite supported this picture of a plume of smoke from source regions down towards southern Ontario, marked off by the carbon monoxide signature measured by our satellite remote sensing techniques. But anyway, that's just one example of a lot of information that's available if you want to look at it. It has happened, been ongoing for quite a long time. So to finish off with, here's a 2010 example. As I said, I wanted to put in a pretty picture just to break up some pages of text, which is pretty boring, really, of course, without a picture on it. Anyway, trends. I'd claim that it's, we have a worsening number of smoke episodes during the past decade just by looking at the sky, saying the sky is messed up and it's really messing up our observations, and it's been worsening during the past decade. And I'd say in the past half century, it used to be a rare situation. I remember, 30 or 40 years ago, but in the past 5 years, it's less and less rare. It's quite common. And this year is way off the charts in terms of severity. And this is, I put subjective observation. That's just my opinion as a sky observer, but that's strongly backed up by fire statistics. So fire stats are much worse this year than have ever been in the record for Canada and USA fire monitoring in terms of hectares burned, number of fires, earliest in the year it's begun. Has happened in past years, in the past 50 years, yes, for sure, but this year is by far the worst ever in record. So it's not just my subjective observation, it's not just my eyes getting, who cataracts or whatever, causing it to be more cloudy or whatever. It's backed up by fire stats that are showing that this is a pretty bad year. So I think I finished off here. I just wanted to summarize. You can forecast this stuff by a combination of observation, satellite imagery, and your eyes looking at the sky, combined with model output guidance. If you want to look at models or other products too, you can combine these together and come up with your forecasts. And I'll have to admit, looking at Astrospheric this year, it is quite a good product too. If you want a one single source that's pretty good most of the time, it's also a very good source. Okay, so that's all I set up to show you. We're all done, Paul. And any questions, I'll be glad to answer them.
Thank you, Frank. Any questions? Right here. Okay.
Looks like Ed has
a couple. Very good.
So typically, I find that, or we used to find that winds from the northwest would really clear out the skies and you get lovely transparent skies and you get great deep sky views. And whereas if it's coming from, say, the southwest, you get a lot of humidity and it gets kind of murky. Now with all the forest fires, is there any wind that does us any good, or are we just going to have to wait for the fires to go to get transparency?
Good question, because this year has been a case of winds from all directions causing trouble. So you're right. In the case of a smokeless sky, north winds usually bring very dry air from the north, very clean, dry air, good for air quality to breathe air, and very good for very deep blue, transparent skies, which helps us out at night. And it used to be that when we get a southwest wind, it was increasing humidity and we expect more haziness. However, this year, a lot of smoke comes from the north. We've had cases where smoke plume has gone to our southwest, and then when the wind has become from the southwest, it blew the smoke plume over us. Sort of happened today with the west wind. The big smoke plume last couple of days, when it came down to our west, thought it was going to hang around there over across southern Ontario and Michigan, and maybe not bother us, but it came, then it drifted eastward over us right now. The worst case was in June. So far, the worst case was in June when we had northeast, when air quality was okay, we didn't have too much smoke, but forest fires over Quebec caused a lot of smoke, affected the Ottawa area. And it didn't affect us until a good northeast wind came. Now, I always say the best observing skies come with a northeast wind. That's because we have a low pressure area to our south, high pressure to our north. The wind flow is from northeast, and that brings the driest, clearest, cleanest air across Ontario for the very best observing conditions. You don't even need to worry about dew on that situation because it's very dry air. So low humidity, clear sky, very transparent air when we have northeast winds most of the time. But this year in June, northeast winds brought us the worst air quality ever in measured in southern Ontario in about 20 years of measuring it. And many cities across eastern USA as well. But northeast winds, bad luck. Southwest, pretty bad. Northwest winds, pretty bad. Have we had any bad cases from the southeast? Not really. But of course, when we have a southeast wind, it's usually ahead of a low pressure area and you have increasing cloud. So to answer your question, it's a good question because it means that hadn't thought of it that way, but we've had bad smoke episodes from all directions this year. So it's been worse every year in that case too. So good question.
Okay, we have a question here.
It's a quick question. The resources that you mentioned earlier, do you know if there's a lag in between what is happening and if I were to observe it now, what's the time period lag in that?
Yes, there is a slight lag because one example is a daily analysis that I showed is put out sometime around mid-morning, and it's caused by analysts. Maybe they start at 7 or 8 o'clock in the morning. It takes a couple hours to put a chart together and put it on the website. But yes, it's a little bit late by the time you see it. However, smoke tends not to move too much in a few hours. So smoke generally moves in one day a fairly distinguishable amount unless you have really strong, powerful winds like in a jet stream, which does happen. Generally that lag that does exist doesn't affect us. Or in other words, the products are still quite good. And so the forecast products by the computer models are still valid. They don't tend to get out of date. They're still pretty good. The analysis products are pretty good. So the answer is it's not really a problem. But as I mentioned, that's why observing using satellite imagery, looking at the actual satellite image is a very good technique to develop as well. Just so you keep an eye on what's happening where, and if the analysis charts are a little late or a little out of kilter with what's actually happening. But in my experience, I've looked at them every day for decades. It's not really a problem. Okay, any other questions?
Okay, Frank, we've got a couple of questions online here. First one from Lewis. How does smoke affect the high altitude observatories other than Canada, like those in California, the Alps, Hawaii, etc.?
Well, it's easy to answer with Hawaii. I'm not aware of any forest fire sources upstream of Hawaii. I'd have to say I've never heard of any problem affecting California. A few years ago, Oregon was heavily hit by, and Oregon is a fairly high desert. Part of Oregon is a fairly high desert, and they were affected badly by a Canadian forest fire smoke that moved southward quite a lot. So the more general answer to your question is it's quite possible for high altitude to be affected by it. So one detail about the weather chart I showed it as 850 millibar level, which is about 3 kilometers height. This often turns out to be a reasonable transport level as one way to word it for. It matches up with the movement of the smoke with the winds that you see in a forecast chart. However, 850 millibar often isn't quite the right height. Sometimes 700 millibar, sometimes 500 millibar is a better chart to use, and it's about 18,000 feet. So it's much higher in the atmosphere. And it's better, matches up better with where the smoke is. So it indicates the smoke is very high altitude. So that's why I say that high altitude smoke can exist and it can affect observatories. We don't hear about it too often from California and those big Western observatories because they're mostly upwind of most of the smoke sources. Bit of a change a few years ago, maybe it was 5 years ago, huge fires in Yosemite Park up in the California mountains and elsewhere. But and California does get a lot of wildfires too, but it probably is a case of it being mostly upwind of most of the sources. So that most of the sources being across the central part of North America, such as right now across northern Canada and northern Alberta and Saskatchewan, bad source right now. That affected eastern USA. Occasionally, some years, it's been a bad fire situation in areas further east of California, including Colorado and Arizona and New Mexico. But I think the main reason why the major observatories in California don't get affected by it too often is because they're upwind of most of the potential smoke sources. But this smoke can be high enough to affect high altitude observatories, yes.
Great. One other, we got one question from Victor Ouyong. I hope I pronounced that right. Does light fire smoke negatively affect the mirrors for those with reflector or catadioptric telescopes?
I couldn't quite get that. Could you read that? Repeat the
Yeah,
question?
does light fire smoke negatively affect the mirrors for those with reflector or catadioptric telescopes? Sorry.
So I think the question is referring to ground level smoke. That's how I would interpret it. So yes, corrector plates on the front. Yes, I would say my opinion, since I have numerous telescopes that use front end corrector plates, I would say no, because by the time the smoke, local light smoke is thick enough to affect the your corrector plate, you're choking in smoke. That's my impression. That's my impression. And furthermore, the regular air pollution that deposits with dew on the corrector plate is worse. It'll affect it far more often than any smoke. So that's my impression.
Okay. Excellent answer. Eric Briggs wanted to know if you had mentioned the blue sun phenomenon from September 1950 due to wildfire smoke.
I didn't mention a lot of famous cases of smoke, historical smoke episodes. Didn't want to mention them. One interesting point about Eric's comment is the blue moon. I think it was briefly mentioned earlier about the blue moon being the not only the second full moon in a month, but also being caused by wildfire smoke traditionally in the summertime. But drifting away from Eric's question, I think it was again. Did I mention it or make note of it? Well, the point was there have been episodes in the past where smoke has been so bad caused a blue moon, but it's far better known for causing diminished sunrises and sunsets. Not only red, but gray. You know, when the sunset in a cloudless sky is gray rather than not even red. So yes, blue moon, yes, but it's more noticeable in other cases like the sunset and brown or gray colored clear sky.
Thanks. Just curious, how long does the smoke persist after the source is extinguished? And is there a difference between the gaseous and the particulate components?
Yes, very interesting question about atmospheric chemistry and also about dispersion of plumes. I would say that regarding the length, the duration of the smoke after leaves the fire, it persists for approximately a week. So if a fire goes out, and fires do go out because of heavy rainfall events that extinguish major forest fire events, and say, take your pick, northern Alberta or some area upwind of us, where there's a big cluster of storms, it gets extinguished by heavy rainfall. That smoke can persist for about a week, depending on the winds. So if it's really strong winds in just the right direction, they can blow it out toward, and Europe complains about it, and a few days later. But there can be light winds where we're well south of the jet stream, or the jet stream is too far north. And so we just have light winds, and so that the smoke plume drifts around, persists around. This is the problem in the middle of summer too, but the smoke plume doesn't really move very fast, and you see it on, you observe it on your satellite imagery as just drifting around and partially breaking up and taking its sweet time to go anywhere, and it's a nuisance for generally a week afterwards. As for transformations, yes, it's a huge subject. Where should I start about chemical transformations? There's oxidants, there's heavy particulate, there are lighter components of the smoke that drift out or react earlier. So a lot of things can change. A lot of things can change to more acidic components of the smoke that can get more dissolved in moisture and rain out, or other components are more inorganic and they tend to persist longer because they don't react chemically. So chemical transformations, very interesting subject. I would just say that some components of the fire, depending on, I should mention there's crown fires, and there are fires that are burned from the base of the trees, and there are ground fires where the fire is on the ground and put different components into the smoke, goes into the atmosphere. So anyway, a smoke plume is composed of a lot of different components, some of which react and can become acidic and more prone to dissolving in water and getting washed out and removed, and others are more inorganic and more inert and don't transform or move or get washed out. So big subject, but the bottom line is it's a big mixture of components, that some of which get removed quickly and some don't. So I guess I'll leave it at that.
Okay. Frank, I have a two-part question myself. Say you're looking at a visible light satellite image. Can you tell the difference between smoke and regular haze? And does it matter when it comes to visual observing whether it's smoke or haze?
The second question is easier to answer because it doesn't matter. Smoke or haze doesn't matter because low-level haze is going nowhere generally. So if you're out for a few hours in an otherwise clear night, it doesn't matter. Your views of, say, deep sky objects are messed up, whether it's smoke or haze. the first question was, can you tell? So one thing I took out here to try to shorten the presentation was a satellite image loop. And the one I had was from a couple of weeks ago. It was from June, actually, where if I showed the loop, click on the movie. Now, it's a good way to mess up a presentation and say, why the heck isn't this working and why doesn't it work? And even with floodlights in my eyes, I probably wouldn't be able to tell, and it wouldn't be a very good presentation subject. But if I did a loop of satellite imagery, you'd see, for instance, this huge plume across eastern Ontario would be moving very slowly. You'd be able to pick out these cumulus clouds. I can't really get control with the mousey here, but there it is here. Maybe I can. You'd see these cumulus clouds coming and going and popping up and going down, and you'd see mid-level clouds like these ones up here gradually scooting through, and the smoke would be easier to see. And with some practice, the answer to your question is you can distinguish it easily from cirrus cloud. So cirrus cloud moves in bands generally with jet stream speeds. The smoke plumes are generally lower than the jet stream, and you see them persisting longer, especially when you stay on the correct image. But so the short answer, yes, with an image loop of a couple of hours, you can easily pick out smoke, and that's why I say if you want to observe it, develop this technique. It doesn't take much practice. It becomes obvious after a little while, especially these days. This past month, with a lot of examples of smoke in the air, where sky is clear otherwise, you can see smoke moving, and so. Yes, you can pick it out. The trickier thing might be picking out, confusing it in the morning with ground level fog. So you see this big plume across eastern Ontario. You could say that's what ground level fog looks like in the morning. Now, I deliberately put in afternoon images. So these are 21 Zulu is about 5 p.m. Eastern Daylight Time in the afternoon. So afternoon image. Morning fog is long gone, but if you look early enough in the morning, you can pick out fog that looks fairly similar to the smoke and doesn't really move anywhere. But yet by afternoon, that is definitely a smoke plume, and you can distinguish it from mid-level clouds, low-level clouds, and high-level clouds with a little bit of practice.
All right. Any more questions? Good. Thank you very much, Frank.